Backtracking.
We did 43.
Oh, right, yeah. 35. I didn't necessarily plan on doing more of these, but thought this would be good practice. So number 35. If you looked at 35 from a math perspective, you can say, well, acceleration equals force divided by mass, right? So you could say 2 newtons divided by 2 kilograms. Another way to look at this, though, is just conceptually. You can say, well, if you were to double the force and force only, what would that do to acceleration?
Cut it in half.
What do to the acceleration? So force and acceleration are directly proportional, so what? Say it again. You're going to double acceleration. Well, if you double the mass, though, what happens to the acceleration? 1/2. But if you do both at the same time, which in freely falling objects, that's exactly what happens.
The mass doubles in freely falling objects?
Well, let's say if you have 2 falling objects and one is twice as massive as the other, what's true about the force on that twice as massive object? It's twice as much force. So if you double the force and mass, then what happens to the acceleration? Instead of doubling because of force and halving because of mass, it's the same as before. Make sense? 36. Pause it. Yeah.
So each one has 30,000?
Right.
Okay.
So you have this plane. It is a lovely plane. It is 30,000 kilograms. And each of its engines.
I love these math problems. I hate problems that are not like this.
Well, that's good that you like these. Some people hate these. So each one of these arrows, each one of these engines has 30,000 newtons of force. So you have a total force of, or a net force, equals 120,000 newtons. You seen a common theme? Acceleration equals force divided by mass. It's just different applications of the same thing. 120,000 newtons, the force, divided by 30,000 kilograms, the mass, equals 4. What's the unit? Meters per second every second. So with every second, it will gain a speed of 4 meters per second. Yeah, let's do 37 again. Not again. Let's do 37. What? Well, I guess we'll resume it. What we did was we used force equals ma to get 6 newtons. 2 times 3 equals 6, right there. And then used force over here. It said it has the same force, so we use that force here. The same force. 6 newtons, 6 newtons. This time, they're 4 kilograms, so you put that in for the mass. Divide 6 by 4 to get x, that's what you have, 1.5. Or, you can say, well, the mass has been doubled, and since they're inversely mass and acceleration are inversely proportional, that means when you double the mass, you cut the acceleration in half. So, half of the previous acceleration is 1.5. Sorry, everyone in the room, for having to bear that again.
How do you stop it?
We'll move to the... Oh, so it doesn't take up more time on the YouTube video, because you guys are just working it out. Okay, 38. So we have a box, right? It is moved across a frictionless, no, not frictionless. What do we know about this?
It has 100.
A horizontal force of 100 newtons.
Horizontal force.
At constant speed.
All right, another thing we know is constant speed. That's the big deal. Anytime you see constant speed, what do we know?
And that force is 0.
Net force is 0.
Yes.
So, what other forces need to be there in order for net force to be 0?
Friction.
100 newtons of friction.
We need 100 newtons in the opposite direction of friction.
Yeah.
Holler. Ah, come on. Stop it. Stop it. Hey. Hey.
Can I try to ride on that thoughts?
Yeah. I think we're running a little faster than the other class did, so. All right, 39. This is a good one. This is a really good one. It exposes something that we haven't seen with the others. But this is a good one too. Sorry, this is not the one I wanted to show. But, okay. It is a 4-jet engine. Accelerates down the runway at 2 meters per second. So it's going like this. Jet. Boom. Hey, I'm a plane. Hey.
Wow.
What is that?
It's my plane. Seriously, guys.
What?
You need to appreciate art. All
I
right?
don't even see
This
It's
is
abstract.
personal expression. I don't care if it doesn't mean anything to you. It's going 2 meters per second squared acceleration, right? This is before, right? And after, what do we know? Christina. So after, yep, there's my plane. After, what's true about the force? What's true about the force?
It's less.
Force is, how does it relate to before?
It's gonna be less.
How much less?
0.5 less.
0.5 less?
Because each
When you-
engine was exerting 0.5 amount of force,
Right.
therefore losing one would subtract 0.5, therefore it is 1.5.
Right.
Boom.
So force is 3/4 from before. So if force is 3/4 from before, what's going to happen to acceleration? 3/4 of before. So it's 1.5. So that's, I mean, the easiest way is to say, all right, what does the force do? The acceleration does the exact same thing. What does mass do? The acceleration does the inverse of that. That'll save you lots of headache and heartache. Yes, heartache. Number 40 shuts down. All right, so the acceleration of a skydiver. In normal conditions, what's acceleration? Meters per second
Squared.
squared. Let's say it has air resistance. How much air resistance? 1/2 of gravity. That's what it says, right?
Half of the dude. Half of the person's weight.
Uh-huh. And that is the force of gravity. Weight is the force of gravity on a person. Yes? If you don't know that, that's a good thing to know.
Yes.
Weight is the force of gravity.
He has a high 9.8.
Um,
I don't know why.
this
I thought that.
9.8 is the acceleration, right? Or if you look at it this way, 9.8 newtons for every kilogram. Okay? Obviously, a person doesn't weigh a kilogram, right? You're going to weigh a lot more. So half of gravity is, that's how much air resistance there is. So what's the net force then compared to before?
Half?
Half. What direction?
Oh.
Net force is half of gravity, half of the force of gravity downward.
That's the answer.
No.
What?
If the net force is half of gravity, then what happens to acceleration? Half of normal. So, and what is normal? 9.8. So what is it?
4.7.
No. 4.9 meters per second squared.
That's the answer.
Mhm.
Pretty much what I said.
Yeah. I mean, this is all just different looks at the acceleration equals force over mass. Well, it makes sense because that's what the whole chapter is about.
Yes.
No, I have a couple more. The 41 is the one that I thought, it's good. No, 41. If a loaded truck can accelerate at 1 meter per second squared, loses its load and has 3/4 of the original mass, what acceleration can it attain from the same driving force? Zoom. Okay, 41. This truck, before it is accelerating how much?
1 meter per second.
After, what else do we know? After, what happens? This mass is 3/4 from before. So, according to the inversely proportional principle we've learned, acceleration is 4/3 indirectly proportional. 4/3 of before. So, it equals 1.3, repeating, meters per second squared. All right, now I'm going to tie this in a little bit to something we've done before. We'll bring Jack and Jill back. Jill is pushing with 550. So this is 40 degrees. I'm putting the angle at a different spot this time. This is a 40-degree angle. 700 newtons. This car weighs 1,500 kilograms. What is the car's acceleration? Don't shut down on me now. No. It's not that hard. Just apply what you've done already today.
Yeah, I don't know what you have to do.
What
You have to do the sine, cosine stuff, and then add
you
to
will
that, and then do the force equals mass times acceleration.
find the acceleration. So start out with what you need to figure out.
The 700, the
Well,
horizontal
what you need to figure out. What do you need to figure out?
Force this direction.
In the end, what's your main goal?
Find the acceleration.
You always want to keep the main goal in mind. So you're after, this is your main goal right now. That's your vision. You'll need to do that stuff in the process. Yeah, I gave the exact same problem. Got it?
Okay. And that,
2/3. Oh. Yeah.
Point 666633333. 2/3. Ole!
Good. So we have that. We had to make this angle bigger. For those listening at home, this is 40 degrees. So in order to find this side, this is the side we're after because we want to find out the amount of force that's in the direction of the object. So we want to find this guy right here. So because it is opposite of the 40-degree angle, we have sine the angle equals what, Zach?
It will equal opposite of the hypotenuse.
And what's the hypotenuse?
It's 700.
So sine of theta equals x over 700 newtons.
So sine of 40.
So bring that 700 over, 700 newtons times sine of the angle equals x. Oh, by the way, that angle is 40 degrees. And what is x then?
It's 999. No, that was good.
That was
5.
It was something.
That x added to 550 was 999.95.
It's true. So it's about 450.
Okay.
450 newtons equals x. So then you add that 450 newtons to the 500 that Jill already puts on. So that's 1,000 newtons total net force. Divided by mass. So 1,000 newtons divided by, why is it so choppy? 1,000 newtons divided by 1,500 kilograms. That is so weird. Equals 2. That looks awesome. I kind of like
That is
it.
really
Oh, it
Two-
looks like
2/3.
blood.
And what's the unit we have?
I mean, like it looks like horror-ish.
Hey,
on fire.
what are units?
Meters per second squared.
Per second squared.
It's on
That's
fire.
so sweet.
Put it red. Put it in red.
Put it.
It's
All right.
on fire.
Hello.
Oh, now you broke.
Oh, I know. It's telling me to recharge the battery.
And it's dead.
Well, guess what?
Are you
It's a
kidding
good thing.
me, Marvin?
We all wanted to try to write.
I'm sorry.
Can we draw a picture on it with the pens?
Yeah, you can go on the board.
I'm angry. I am so angry.
Right when we're finishing.
Stop record.